What kind of problems were we solving yesterday? What were we solving yesterday? If you can't remember, maybe take a look at this picture and see if that helps. Yeah, we were sharing chocolate bars, right? So we were thinking about how siblings could share the pieces of chocolate and chocolate bars in a way that felt fair based on their ages. So we said if Carter was 6 years old and Jordan was 12 years old, and if there are 18 pieces in this chocolate bar, then maybe they could share it so that Jordan got 6 pieces and Carter got 12 pieces, because then each sibling would have 1 piece for every year of their age. And we used some math language to talk about that. We said they were sharing the chocolate bar in a ratio of 6 to 12. So ratios are a comparison based on multiplication. And that language for every was useful for us to use to talk about ratios. So we said things like, for every 6 pieces Jordan gets, Carter gets 12 pieces. And then we kept thinking about that ratio and said, I wonder if we could share in the same ratio even if there's different numbers of pieces of chocolate in the bar. So what if there were only 9 pieces in this chocolate bar? How could Jordan and Carter share it in the same ratio if there's only 9 pieces? Okay, I'm hearing Jordan would get 3 pieces and Carter would get 6 pieces. Why? Why do you think that? I see. So the pieces in them, when there's only 9 pieces of the chocolate bar, they're bigger, so they're kind of worth 2 of the pieces when there's 18 pieces in the chocolate bar, right? So it makes sense that Jordan would get 3 and Carter would get 6 in this case because they get the same amount of chocolate that way. So in this case, they're sharing the chocolate in a ratio of 3 to 6. And we said those 2 ratios are equivalent. 6 to 12 is equivalent to 3 to 6. We can see they're equivalent because in each case, the siblings get the same fraction or amount of chocolate in the chocolate bar. Great. So we're going to keep thinking about ratios and equivalent ratios today, but we're going to use a different tool to think about it. Instead of using pictures every time, we're going to use tables. Not the kind of tables you're sitting at, but instead tables where we organize information, or data tables. When have you used a data table before? Maybe you've had to look something up on a table, or you wrote something down in a table. Oh yeah, I think that's a great example. Your school schedule is in a table. What makes this a table? How do you know it's a table when you look at it? Yeah, the rows and columns, right? Tables always have rows and columns. That's how we organize the information in the tables. Rows and columns are really useful because they keep all the related information together. So for example, the start time column in this table has all the start times for all the classes in it. And like in the math class row, we have all the information about math class. So tables make it really easy to find important information. Because we like to find the start time of math class, we would just go to the row for math class and the column for start time, and there it is. Math class starts at 10:05. So the rows and columns in tables are a really useful way to show important information. It sounds familiar to me. When have we talked about showing or representing important information before? I feel like we had a word for that. Yeah, abstraction, it's one of our CT practices. So when we're doing abstraction, we are identifying and representing important information in a problem or situation. So we're going to keep doing that today. We're going to think about how we can use tables to identify and represent important information in rate problems. So let's think about that. Let's look at this table. So you're going to see a lot of tables like this in your math book. And when tables show equivalent ratios like this one, we can call them rate tables. So what are the rows and columns doing in this table? How are they helpful? Let's look at that 6 and the 12 in the first column there. What is that telling us about the problem? What did that 6 and 12 represent in those problems about chocolate bars we were just talking about? Yeah, we said that when there were 18 pieces in the chocolate bar, Jordan got 6 and Carter got 12. So why are those two numbers together in the same column? Yeah, it makes sense that they would because they're related, right? They're the two parts of the same ratio. So the columns in a rate table always show the two parts of a ratio together. What about the rows? How is the information in each row related? Yeah, the labels help us out there, right? So all the pieces that Jordan gets in each chocolate bar are on the top, and all the pieces that Carter gets are in the second row there. Tables are useful because they show a lot of important information in a really small space. So all that information we had in our two pictures is actually just in two columns of this table. So our ratio of 6 to 12 is in the first column, and our ratio of 3 to 6 is in the second column. And there's actually space for a lot more ratios as well. So not only is 6 to 12 equivalent to 3 to 6, in this table we can also see it's equivalent to a ratio of 1 to 2, and 2 to 4, and so on. And there's even space to show more equivalent ratios if we add another column. So let's think about that. Let's add another equivalent ratio in a new column. So if Jordan got 20 pieces of chocolate, how many would Carter get? 40? I'm hearing 40. Why 40? Yeah. So it looks like in this table that to get the number of pieces for Carter, it's always twice the number of pieces that Jordan got. So if Jordan's getting 20, then it makes sense that Carter would get 40. Great, you're off to a great start using tables as a tool for abstraction as you work on these rate problems. I'm going to let you keep working on the problems now, and after a while we'll come back together and talk about how those tables were useful. Thank you for sharing all your thinking about how you were solving the rate problems. It was great to hear all the great thinking. I heard a lot of you talking about using patterns to fill in your rate tables. And especially I heard a lot of people talking about multiplication. So for example, in this problem about Jordan and Carter, you were saying a lot of things like, oh, to get Carter's pieces, I can just multiply the number of pieces Jordan has by 2. And it makes sense that you were thinking about multiplication because ratios are comparisons based on multiplication. Here's my question though. How were the tables helpful when you were looking for patterns? How do the tables help you see those patterns? Yeah, all the stuff that you needed was kind of all grouped together, right? So you knew that those ratios were always going to be together in the same column, and you knew that Jordan's were always going to be on top, so it just got really easy to see how the numbers were related, right? So tables are just really useful for abstraction because they not only give us a place to write numbers down, but a way to organize them so we can see how the numbers are related. So now that we've had some practice using tables for abstraction, let's keep thinking about how they might be useful. I bet we're going to find other places where tables can be useful for helping us solve math problems.